Hello friends, this is Priyanka. Today we are going to solve a problem on bypass factor of heating coil with the help of psychrometric chart. So in this problem we are going to find out what is the air per minute which bypass the coil and heat added by the coil. So first I will read what is the given problem. The moist air is heated by steam condensing inside the tubes if a heating coil as shown in figure. The part of air passes through the coil and part is bypassed around the coil. The barometric pressure is 1 bar. Determine air per minute which bypass the coil and heat added by the coil. So this was the given problem. So let us first understand what is the given diagram. Now if we observe, here is the structure for this coil or heating coil is given. So what is the initial condition of air when it is getting entered through this coil? So if we observe here the mass flow rate, that is 60 kg per minute, dry bulb temperature 5 degrees Celsius and the relative humidity 100% is given. Now if we observe when this air is entered into this coil, it is split into two parts. One part is passed over this coil and the other part is passed around this or bypasses here from this path. So we will consider initially 1 kilogram of air is admitted at point 1. Then what is happening out of 1 kilogram, the x kilogram of air bypasses the coil and remaining 1 minus x kilogram of air moving over this coil. So what is the condition of air at this coil given? So here relative humidity, that is 20%, is given. Then what is happening at the exit of this coil? The dry bulb temperature, that is at point 2, is given, that is 24 degrees Celsius. So this is the data that is given in the question. So we will write what is the initial condition of air, that is at point 1. So if we observe the initial condition, that is this point 1, we will say here the dry bulb temperature is 5 degrees Celsius, relative humidity 100% and mass flow rate 60 kg per minute. Now according to this data, we will plot the point 1 on the psychrometric chart. So how to plot? So here the dry bulb temperature in degrees Celsius, that is 5 degrees Celsius, is given. So here is the 5 degrees Celsius and relative humidity. So this inclined blue colored line indicates the relative humidity in percentage. 40%, 60%, 80% and 100%. So on this 100% line, we have to extend this dry bulb temperature. So here if we extend this 5 degrees Celsius, this point of intersection will give us the point 1. So this is the selection of the point 1 for the initial condition of the air. Now we will move for the next. So what is the final condition of air, that is at the exit of the coil? So we know that at exit of the coil, the dry bulb temperature, that is given 24 degrees Celsius. And what is the condition of air at heating coil? So at heating coil, that is at point 3, relative humidity is given, that is 20%. Now according to this data, we have to plot the point 2 as well as point 3 because the point 1 is getting selected. Now here with reference to the point 1, this point 2 and point 3 are getting selected. Now how to select these 2 points? Now at point 2, the dry bulb temperature is given, that is 24 degrees Celsius. So here is 20 and 25. There are total 5 partitions. So we have to select here the temperature with 24 degrees Celsius. Now when the air is moving from this point 1 to point 3 or point 1 to point 2, the specific humidity remains constant. So we have to draw here the horizontal line for this constant specific humidity, because specific humidity is plotted on this vertical line. So we have to keep the specific humidity constant. So where this dry bulb temperature, that is 24 degrees Celsius dry bulb temperature, and the specific humidity intersect at a particular point, and that point will be our point 2. Now, what about the point 3? So here the relative humidity is given, that is 20%. Now, if we observe these blue inclined lines, so these lines are having the relative humidity 20%. So this inclined line and the horizontal line for the specific humidity coming from this point 1 intersect at particular point, and that point will be our point 3. So this is the selection of point 1, 2 and 3. Now we will consider 1 kilogram of air being admitted at point 1. So if we observe the diagram here, at the entrance we will consider 1 kilogram of air admitted in this coil, and it is getting splitted into two parts. So air bypassed unaffected, that will be x kilogram. So here from this path air is getting bypassed, and that will be equal to x kilogram. So x kilogram of air is getting bypassed out of 1 kilogram. Then what is the remaining air? That is 1 minus x. So this air passed over heating coil is equal to 1 minus x kilogram. So in this diagram this data is clearly shown. Now we will find out what is the enthalpy at this point 1, 2 and 3. So if we observe here, the enthalpy is given in kilojoule per kilogram of dry air. So on these inclined lines, this is the enthalpy. Now from these inclined lines, there is the continuous straight lines that we can see clearly. So we have to take the parallel lines but passing through the selected points. So if we take the parallel line to this enthalpy line but from this point 1, then what is the exact value for this enthalpy? That is H1 is equal to 19 kilojoule per kilogram of dry air. So we have to select the same unit as per given in this psychrometric chart. Then what is the enthalpy at point 2? So from this point 2, here is the enthalpy line that I have shown with this green line. Then H2 is equal to 38 kilojoule per kilogram of dry air. Then what about the point 3? So here is the point 3, that is H3 is equal to 44.8 kilojoule per kilogram of dry air. So we will select here what is the dry bulb temperature at this point 3. So if we observe, because of the selected points, what is the dry bulb temperature? So here is 20, with the help of this 20% relative humidity, we have selected this point 3. So if we extend this point on this dry bulb temperature, here TD3 is equal to 30.8 degree Celsius. So this is the value of dry bulb temperature at point C. So this is the data that we have to note down. Then we will calculate what is the amount of X. So what is the amount of X? That is the air per minute which bypass the coil that we have considered earlier. So we have to calculate it. So for that we have to use the formula for the bypass factor. So what is the formula? So it is related to this dry bulb temperature. So how we can write this formula? Now that is formula is equal to this TD3, that is the dry bulb temperature at this point 3 minus TD2, that is the dry bulb temperature at this point 2, divided by TD3 minus TD1. So this is the formula. So we know what are the different temperatures at this point 3, 2 and 1. So simply we have to put the values, and so 30.8 minus 24 divided by 30.8 minus 5. So when we calculate this, we will get the amount of x is equal to 0.264. Now for this x we have already considered, that is the amount of air admitted at point 1 is equal to 1 kilogram. So out of 1 kilogram, this is the amount of air that is getting bypassed, that is 0.264. So in the question, it is given that what is the total amount of air admitted or mass flow rate of air, that is 60 kilogram per minute, that is given. So air, that is the total air which bypass the coil. So we have to multiply this x multiplied by ma, that is the mass flow rate of air. So this mass flow rate of air in the diagram, that is given 60 kilogram per minute multiplied by 0.264. So which is equal to 15.84 kilogram per minute. So this is the answer. Now what is the heat added by the coil? So that is the enthalpy difference multiplied by the mass flow rate of air. So we have to take the enthalpy difference in between point 2 and 1, that is at the exit of the coil and at the entrance of the coil. So 60 multiplied by 38 minus 19, which is equal to 1140 kilojoule per minute. So this is the answer.